Hello, everybody, and welcome to your linear algebra review on matrix multiplication. My name is Jason, and I work for the ASU Tutoring Center. Now, matrix multiplication, there's a very specific rule to decide if you can multiply two matrices together, okay? So for instance, let's say you have a matrix A, and it is an m by n matrix. So that means it has m rows and n columns. Okay. If you want to multiply it by a matrix, so if you want to multiply it by another matrix B, the number of rows that B needs to have is also n. So B, for instance, can be some n by P matrix. So P is just some other number. Okay. So the big thing is if you want to multiply two matrices A and B together, the number of columns of the first one has to equal the number of rows of the second one. That is a requirement. Okay. And when you do the multiplication, you'll get another matrix out of it. And the dimensions of this matrix are m by p. So basically, the n, the thing that's matched up, goes away, and you're left with an m by p matrix. Kind of looks like a smiley face, doesn't it? Look at that. It's so happy. Oh. So when you multiply two matrices together, you need to ensure that the number of rows on the number of columns on the first one and the number of rows on the second one match up. And once you do the multiplication, the dimensions of that matrix that comes out of it will be the number of rows of the first one and the times the number of columns of the second one. Okay, so that's the general rule for matrix multiplication. Now keep in mind, multiplying two matrices A and B together, it very much depends on which side they are on. So multiplying the matrix A by the matrix B is not necessarily the same thing as multiplying B by A. There are some matrices where that is true, where they do equal each other. But as a general rule, this is not true. A times B is not necessarily equal to B times A. And I mean, we can see that just based on this rule, right? So say A was like a 2 by 3 matrix and B was a 3 by 1. Well, we're allowed to do A times B then, right? Because A has 3 rows, 3 columns, and B has 3 rows. So because these match up, we're allowed to multiply them. But if you took that same A and that same B and tried to do B times A, we would have a 3 by 1 matrix times a 2 by 3 matrix. And these do not match up. So we can't even multiply B times A. So there are some cases where you can't even do the other operation of B times A. So the order you multiply matrices in is very, very important. And you can't just change the order up willy-nilly. Okay. All right, so let's see it in action. Let's first decide which of these matrices can in fact be multiplied together. So let's look at the dimensions of this first one. So it has 1 row and 2 columns, so it is a 1 by 2 matrix. And then this one, it has 2 rows and 1 column, so it is a 2 by 1 matrix. So yes, in fact, we can multiply them together because these two inside numbers match up. And beyond that, we know the dimensions of the matrix that comes out of it. It would be some 1 by 1 matrix, okay? Because there's the 1 on this outside here and the 1 on this outside there. So we already know the dimensions of that matrix that comes out of it, okay? Cool. So first one we can in fact multiply. We'll go ahead and put a check mark next to it. Let's look at the question B. So this one has 2 rows, 3 columns. This is a 2 by 3 being multiplied by something that has 2 rows, 1 column, 2 by 1. These middle two numbers do not match. Therefore, we cannot multiply those together. Let's try it here. So part C, there's a 3 by 2 matrix, 3 rows, 2 columns, and this has 2 rows, 1 column. This inside does match, so we can in fact multiply them, and our result would be a 3 by 1 matrix. And this last one, we have a 2 by 2 times a 2 by 2. The middle two numbers do match up, so we can multiply them together, and our result would be a 2 by 2 matrix. Okay, so all of them can be multiplied together except for B. So let's go ahead and do the multiplications. So how matrix multiplication works, and it's sort of a process. I always imagine it in my head as you take the rows of your first matrix and you multiply by the columns of your second matrix. So what I do in my head is I think of this row, the row that I have chosen, and I literally imagine it turning in my head. So I see like the 1, -3, and I see it like doing this gradual turning process 3-dimensionally in my head. It's like 1, -3, and then it's like it goes all the way. It goes 1, -3. It's like a slow transition vertically. Okay, that's what I envision in my head. Now it might work differently for you, but this is how I recommend thinking about it. As you think about, you take your row and you imagine it twisting in space, and you're multiplying it by 2 -1/3. And then that multiplication, now that you've twisted it in space, it's done pretty much component-wise. So I would multiply the 1 with the 2, and I'd multiply the -3 with the -1/3. That's why it's beneficial to me to think about it twisting in space, because then it sort of lines them up, right? It lines the 1 with the 2, and it lines up the -3 with the -1/3. And then once you take your row times your column, like we did here, the elements of our row times the elements of our column, we add those elements together. So 1 times 2 is 2, -3 times -1/3 is 1. Adding those together, we get 3. So I took my row and I took my column, I multiplied them together, and I ended up getting 3. So because it was my first row and my first column being multiplied together, that tells me that what is 1, -3, 2, -1/3. It tells me that the first row and the first column of my matrix on the right-hand side of my product matrix is a 3. So maybe it looks something like that. But we actually already know the dimensions of this matrix, right? As we mentioned earlier, this was a 1/2 times a 2/1. So the dimensions of our matrix would be 1/1. So in fact, 3 is the first element in our matrix, and it's the only element in our matrix, because it's a 1/1 matrix. It only has one element. So our result on the right-hand side would just look like that. It's a 1/1 matrix. You get 3 out of it. Now, depending on your class, you can really think about 1/1 matrices just as scalars, right? Because they are, in fact, just a single number, aren't they? So you can think about 1/1 matrices as just scalars. So writing it as 3 with brackets around it is technically fine, but you could also just write it as 3 without the brackets, because it really is just a scalar. Now, that depends on your class. Maybe your professor wants you to keep the brackets. Maybe they specifically don't want you to keep the brackets. It's up to your professor. But to me, you could write either of these, and that would be the correct answer. Okay, so that's the idea behind matrix multiplication. You multiply rows by columns. And in this case, we only had one row, and we only had one column to multiply it by. So we only had to do one operation, one row by one column. But let's see how this works when we have more rows and more columns going on, shall we? Okay, so let me clear that. So let's do part C. So we have 1, 0, -3, 4, 0, 2, multiplied by 5, 1. So what do we do? Well, first of all, what's the dimensions going to be when it comes out? So this is a 3/2 matrix here, being multiplied by a 2/1 matrix. That means our resulting matrix, we sort of just ignore the middle piece, will be a 3/1. So 3 rows with one column, 1, 2, 3 rows. Okay. And how do we get those rows? Well, we do what we did in the previous one. We do rows multiplied by columns. So let's start with this first row. We take the first row and we multiply it by the first column. And we do that component-wise. So again, imagine this 1, 0 like sort of twisting in your head. Think of it almost like that. So then you know, okay, I'm multiplying this 1 by this 5, because they're both on top now. And I'm multiplying this 0 by this 1. That really helps me personally, imagining twisting in space. And then I just multiply across. If that doesn't work for you, that's totally fine. The other way you can just think about it is, so you take your row and you take your column, and you just go, so the first element of your row, you multiply by the first element of your column. The second element of your row, you multiply by the second element of your column. And then the third element in the third, and the fourth and the fourth, and the fifth and the fifth, and however many you have, right? So that's another way you can think about it. Just where it's located in the row, you multiply that by the element that's located in the same spot in the column. Okay, so we would do 1 times 5 plus 0 times 1. Okay, that would be our first element. And then we would go down to the next row, and we'd multiply this row by this column. So we would have -3 times 5 plus 4 times 1. And then we go down to our next row and our column. So we would have 0 times 5 plus 2 times 1. So this gives us 5 plus 0, -15 plus 4, and 0 plus 2. So we get 5, -11, and 2. There we go. Okay, so you multiply rows by columns. And again, you don't have to think of it as twisting in space. That just personally works for me. Okay, so let's do part D. Part D. So this part D is sort of the culmination of it all. So the first one, we just had 1 row, 1 column. The second one, we had several rows, but still 1 column. Now we have several rows and several columns. So it's sort of the, part D is the most general type of matrix that you'll see, of matrix multiplication that you'll see. 2, 4, 6, 0, 1, -1, oops, 0, 3. So what do we do? Well, first of all, let's see the dimensions of what our product matrix would be. So we have a 2 by 2 matrix here and a 2 by 2 matrix here. So ignoring the middle bits, we would be left with a 2 by 2 matrix. So we should have a 2 by 2 matrix. So how do we find the elements of this 2 by 2 matrix? The same exact way. So let's start with our first row and our first column. Okay. So since we're multiplying the first row by the first column, that would give us this position of our matrix, the position that's in the first row and in the first column. Okay, so the first position of our matrix would be 2 times 1 plus 4 times 0, because we're doing this row times this column. So we do this 2 times that 1, and we do this 4 times that 0. Okay, and now we have an option. We can, so we were with this row in this column. So we can either then choose to go down to this row with the first column, or instead of changing rows, we can instead change columns and multiply the 2, 4 by this column. So it's entirely up to you. Personally, for me, what I like to do is I like to just kind of fix my first row and then multiply it through all of my columns. So first I multiplied it to 1, 0 to give us this. And then I'm going to go ahead now and multiply it to -1, 3. And what will that give me in my matrix? Well, this is in the first row and this is in the second column. So it would give me the element that's in the first row and the second column. So it would give me like this element over here. Okay, so let's do it real quick. So I have 2, 4 times 1, -1. So that'd be 2 times 1 plus 4 times -1. Cool. So now I've worked through all the columns, right? There's only 2 columns in my second matrix, and I've multiplied my first row by both of those. So now I can go ahead and move on to my second row. So this is just how I personally do matrix multiplication. I fix a row on this side, and then I multiply it through each of the columns. And that gives me each element as I go through, right? For however many columns I have. In this case, I only have 2 columns, so I only have 2 elements. Cool, now I'm working with my second row, the 6, 0, and then I restart the process. So I do 6, 0 times 1, 0. And where will that be in my matrix? Well, it's the second row times the first column. So that would give me my second row, first column. That would give me this element. Okay, so that element would end up being, it would be 6 times 1 plus 0 times 0. And then if I want my final element in the bottom right position, I multiply 6, 0 by -1, 3. So I have 6 times -1 plus 0 times 3. And then it comes down to simplifying. 2 times 1 is 2, 4 times 0 is 0, 2 plus 0 is 2. And then over here I have 2 minus 4, and then I have 6 plus 0, and then I have negative 6 plus 0. That's what it's going to end up being. Okay, so that if there's any of any of these three that we did, if there's any one to really understand, it's part D. Because part D is where we go to any general matrix multiplication. We do columns, we do rows times columns, rows times columns. And usually the easiest process is to first fix a row. So you would just choose a row over here and fix it, and then go through all the columns in your second matrix and just start multiplying it. So 2, 4 times 1, 0. Then you move on, 2, 4 times negative 1, 3. And then you'd keep moving on until you run out of columns. And once you run out of columns, you restart the process with your next row. And then once you run out of columns again, you restart the process with your next row if you have one. And you just keep doing that. And that's how matrix multiplication is done. Wonderful. Well, thank you for joining me. Let me hop over to this next slide. So as I mentioned at the beginning, I work with ASU tutoring centers. So if you want more information about the free resources that we have available at all 4 major ASU campuses and online, please check out tutoring.asu.edu. If you want more content like this one that went over specific concepts from your course, or if you want to look at upcoming review sessions that we might have for your exams, go ahead and check out this link down here. Thank you again for joining me, and have a fantastic day.